Hello everyone and welcome to another English live stream from Bone Studio. And tonight, well, we are going to make some kaboom things, right? Because since Blender 2.82 has been released, now we have Mantaflow officially implemented in the release version of Blender. And this is very good, this is great. But what can we do with Mantaflow? And in Blender today, well, in fact, in a Blender Hoy, the Spanish streaming from Pablo Vázquez, I asked him, what could I do for a live streaming? And he told me, hey, why don't you do something related to Mantaflow, to how to achieve good results, for example, for explosions or something like that. Okay, so now I did the Spanish live streaming, and while the Spanish live streaming was great, but I had no time to improve it, so right now I'm going to do the same streaming but in English. What does this mean? This means that this stream is not going to fulfill the expectations from Pablo Vázquez, because this is not going to be like the high detailed live streaming about how to do super cool, super great explosions. No. Hello, Michael, Mitchell, I don't know, whatever. Hello! This is going to be like an introduction on how to do explosions, and I'm going to do some kind of experimentation with maybe not different techniques, because I'm not going to have enough time to test different techniques, but this is like the first part of probably 2 parts live streaming. So in the first part, we are going to try the classic technique with some particles. So let's review, first of all, this simulation. This simulation I have here is pretty simple. It's just a monkey, a Susan, that explodes. Okay, it goes kaboom, and that's it. As you can see, this simulation is simulated with a lot of resolution. If I select the domain, you can see that this simulation is done at 600 subdivisions. And no, we don't know. Yeah, Dustin. Now we are talking. We don't need such a big resolution to get good results. But I discovered that after the Spanish live streaming, because at the end of the stream, I did some tests with noise, and the results were pretty great, pretty good. Also, I detected some bugs, or not bugs, but some glitches that we are going to see today, and I will tell you how can they be solved. So basically, this is a super high resolution domain, and it's 600 subdivisions, and you can see that I have dissolve enabled. I will assemble a scene from the beginning later, but right now I'm just doing an overview. So I used adaptive domain, which has a problem that in fact Blender Guru detected today or yesterday, but it has a problem that the adaptive domain cuts the explosion too fast. So I think it's a bug, it's under investigation. And now we have noise with an uprest factor of 2, and here is the real key for the thing. After that, nothing special. I did nothing with forces, with anything. So that's it. But now, how can we get this aspect? Okay, this look. Let me reduce the render. How can we get this aspect for the smoke and for the explosion? Well, first of all, there is an important thing. The simulation is just like 40%, 50% of the result. The other 50% of the result is the shader. The shader, at least in Blender in cycles, the shader is everything. Okay, you have to work with the shader to get good results. This doesn't mean that you need a super complex shader like in the past. So now with the principal volume, we can do a lot of things. But it means that you have to know what you are doing with it. So far, you can see that this is, I think it's a pretty natural looking explosion. Okay, this is detailed. We can go near the explosion and we can see some detail, not as much detail as I wanted. And you can see some glitch also here. Okay, here. You can see like the lines. And you could expect that with 600 subdivisions, we should be able to avoid this kind of problem, right? And yes, you are right. We can avoid this problem, but this is a problem I was talking before, but we will see it, we will see the solution later. So now it's a pretty natural looking explosion, but also another problem you can find is that if we go near the smoke, like really near, imagine that the smoke is coming to the camera and it's like the smoke is eating you. Okay, this is super soft. It's super soft, and we may not want this soft look in the smoke. Okay, we may want like more detail, because in the end what the smoke is a lot of debris and a lot of dust and a lot of particles suspended in air, and those particles are like volumetric, are like a volume in the space when you see it from far away. But when you are near the smoke, especially this kind of smoke, it can be pretty solid and it can have very thin detail. So we are going to try, because I'm not convinced the technique I use is perfect, but we are going to try to get this thin detail in the near plane. Hi Sotomante, no, you are not late. Let me read. Dustin Bowser, how long for the bake on that one? I don't know. I don't know, because I just left it during the night and I went to bed and I don't remember the bake time. But don't worry, you don't need to use this amount of resolution. There's no need for that. Cadist, bueno, tocará preguntar cuando sean. Cadist, I already did the Spanish streaming of this, but I'm going to do the second part. And the second part, I don't know if it will be this week because I'm kind of bored in work, but I will try. If I can, it will be this week. Dustin, yes, that has been my experience with Mantaflow. Too soft and blobby. Yes, it's not just with Mantaflow. In fact, it's practically every smoke simulator out there delivers this kind of softness. If there is a simulator that don't give you this result, it's because the shader is better. Not better as in the shader is better per se, but the shader has more work on it and it has more detail. Hello specs. So it's not a problem of Mantaflow. You can see, for example, the old Maya fluids with the Maya smoke, and the result was this. And even fume effects, up to some point, you may get sometimes you may get this result unless you work with the shading part, because in fume effects, if I recall correctly, the plugin has inside of it the shading part of the smoke. It was not just a material that you can use, a shader that you can use from Manta or from V-Ray. It was a custom shader that came with the plugin. So, as I said, half of the aspect of the result of the simulation is the shading, not just the simulation itself. Hello, VLC. Hello, Devanti. Okay, so let's continue with this. As you can see, in this case, the shader is pretty simple, and I have here a Musgrave, but I'm not going to use the Musgrave yet. Just yet. But you can see that we have a pretty thick smoke. Okay, it's not super thick, it's not like solid, but it is pretty thick. So why is that? Because if you do a simulation with Mantaflow and you leave the shader as it is, the principal volume, we disconnect this and we go to 1, for example, this is what we get. Okay, and this is not cool. We can reduce this. This is not cool. Okay, this is not pretty. This is like, okay, it's a simulation from 20 years ago or 15 years ago, or from the first version of Fume FX or something like that. This is not cool. Why? Because we need to increase the density, to get some result. So we can go here and we can increase the density here. And yes, we start to see something interesting, but still too thin. It's really, really thin. Hello, Boscavidas. Is the same live from the past week in Spanish. Es el mismo directo de la semana pasada en español. But in English. Still too thin, but okay. At this point, it could be useful because you may want explosion and you may want like thin sand or thin smoke. It could be useful, but what if you want like more solid? Okay, you can go and you can increase this to 200, for example, and then we are talking. Okay, then we have like a solid pyroclastic smoke, a solid pyroclastic explosion. It lost a bit of light, but we can increase this by increasing the black body intensity. So we can go 5, for example, or 10, or even 20. Okay. Okay, so we get more light and we get like a more solid result. And we can go crazy and we can go 1000, for example. And this is super solid. And we can go even further and go to 2000. 2000. And we can go even thicker smoke. Okay? 50 or 100 for the black body intensity. Okay, and this is thicker. This is a very, very thick smoke. But it still has like some soft borders. It's not like solid smoke. It's like thick smoke. It's like a lot of smoke, but still soft. So we can do something to solve this. That is work with the color ramp. I'm going to recreate this. So we can use the volume info node and we will get different information from the volume. So we can get color, density, flame art, and temperature. What we want to get the result we want is the density value, density variable. So now we can go and use a color ramp. No, not like follow. Search a color ramp, and we put the color ramp, the density here in the factor, and the color we're going to put the color into the density value. So we can input a color ramp instead of just the number. A number is just a multiplication of the values with a multiplication of the values that are being calculated during the simulation. But now we are going to control those values. So we can go color into the density, and right now it breaks the result. Okay, it just breaks the result. Why it breaks the result? Because now we are multiplying, or we are controlling with the color ramp, but the values go from 0 to 1. What we need is to increase this value. So after the color ramp, we are going to multiply the result. Don't use add, because if you use add and use, for example, 100, you are going to get this. And while it's not bad, it's not the result you want to control this, believe me. So we are going to use multiply, and then we can put the same value we had in density, and now we have the same result, or pretty similar at least. Okay, it's basically the same result. But now we can do this. We can increase the black parts. So as you can see, we are like chopping off parts of the smoke, and we can increase the contrast. So we can increase this, and we are going to get a much more solid smoke. be aware that if you go too far away with this, you go with two big values. Well, in this case, the resolution is 600, so it's not bad. But you can start to see glitches with voxels. And in fact, you can see these glitches here. In this part, you can see that this has like a blocky aspect. So be aware that this is not impressive in that regards, but we can try to do a thing to solve this problem. But we already did this, so you can see that we can increase the contrast, and we can increase the contrast with this too. Or we can do like crazy things. For example, we can use another value here, and let's put black, and another value here, and this is going to be white. No, it's going to be black also, and another value that is going to be white. Okay, so we can control like layers of smoke. I don't know if I will be able to make this too visible. But what we can do with this is to control layers of smoke. So we can divide the smoke in as many layers as we want and play with this and do really crazy things. Also, another thing that we can do with this color ramp technique, it's just colorize the smoke, and this is all news. So this was the thing that has been done during years with the old smoke simulator. So we can color the smoke. We just have to pick another color ramp, and we are going to get the color value here and get the color here, and now we get this gray smoke. But we can go here and let's add this like brown, but it's black, so it has no presence. But I like the gradient. I don't know if this is going to be pretty. It may be ugly. I don't know. And let's saturate it, like more brown. And now we can get another value, and why not? We are going to use blue. Why? Because I want it's going to be ugly. Yeah, I know. Or pink. We can get pink. Okay, so we basically can color the explosion or the smoke with whatever color we want. Many people, I've seen many people using lights to color the smoke. Don't do that, please. The smoke has to be kept as physically correct, and if you use lights to color the smoke, you are going to modify your scene and you are going to modify the result. Use these techniques to color the smoke. Now we can get rid of this, and we can do one final thing before we go to start our own scene from the beginning. That is, how can we solve this glitch that we have here? Well, it turns out that in some way this is kind of a bug. It's not a bug, it's a current limitation of the algorithms being used to calculate fire, because it happens mainly in fire, not too much in smoke. But luckily we have a solution here. We go to material output and we go to settings. In volume we have interpolation. If we change this interpolation to cubic, there is no problem anymore. Okay, the lines go away and we get a much better result. Especially if we render this. Let me create a proper ramp for this. Okay, this is much better. Okay, so this way we don't have the lines glitched anymore. Okay, it's solved. But of course, we still need like more resolution, more detail in the shader. We will see that later. Be aware that this won't solve the problem with the blockiness if you go too far with the contrast. Okay, we do this. Well, it's not bad, but at some point you are going to get, anyways, you are going to get like the blocky aspect. We can try to change to linear, and you can see the lines here. And if we change to cubic, we see that there are no lines. This is part of the simulation. This is not the glitch, but there are no lines. Okay. Now, this is the first part, so to speak, about the shading. Okay? As you can see, many different effects can be achieved with the shader. This is very important. Now let's go to create a simulation, a scene from the beginning. So let's kill this. Let me save this scene. And let's go and create a new scene. So I have my starting scene here, and I delete everything. And I'm going to create a plane. Why do I create a plane? Because I like to have floors. Now I'm going to create a monkey. Hello, Susie. Okay. Here I have scale 2 meters by 1 meter, a bit smaller. Okay. JFriend MG, in theory the new map range node is better than the color ramp, at least for basic stuff. Yes, it's better, but you cannot do with the map range, you cannot do what I did. I mean, you cannot separate different layers of the smoke simulation. And while in the example I used is not such a big deal, you can do many pretty things, many cool things with the color ramp, and doing different ranges of smoke. So the map range is great, and it can gain contrast very fast, and is numeric, is controlled by numbers. But with the color ramp you have more control regarding the different layers. So they are just two different techniques, and they could be even mixed. So they are just two different techniques. Okay, now how can we create the simulation? First of all, please save your scene. Before you are going to do anything, save your scene. So monkey explode English. Why? Because if you have your scene saved, you are going to have a comfortable folder for the cache. If you don't save the scene before, you are going to get the cache in the main drive, or in the temporary drive, in the temporary folder of your operating system, and you may end losing some part of the cache. And you may run into problems like, oh, why I'm unable to see the simulation in the viewport. And many times it's because this problem, because the cache folder is not correctly configured, and then the simulation is not being able to read the cache. Let me drink. Okay, 24 minutes, not bad. So first of all, save your scene. Second of all, you just saw me scale the monkey. You just saw me scale the monkey, okay? But what was the second thing I did after I scaled the monkey? Please, Control A, apply scale. Always, with everything you are going to use, at least with physics simulations, you have to have the scale applied. This is a must, okay? Everything that you are going to use inside the simulation, you have to have the scale applied. And as a general rule of thumb, you have to have the scale applied in any object you have in the scene, okay? This will save you a tons of problems with modifiers, with rigs, with whatever. So you have to have the scale of it. And next, we can do two things to create a fluid simulation, a smoke simulation with this monkey. First one is that we can go to quick smoke and we can press quick smoke, and it will create like a setup where it will apply the material to the domain, and it will create like basic settings and a domain that is going to be around the monkey and etc. But I'm not going to do this. Okay, it's a quick way, but I want to show you how to do it manually. So instead of using quick smoke, we are going to use the other route, that is manually creation. So first of all, we need our domain, just a cube, scale the cube as much as you want, but keep in mind that as much as one, it means that if it's too big, you are going to get a slow simulation. So a bit more because it's explosion. Okay, hey, here. Okay, enough. And what should I do now? Apply scale. Always, please. Always. Next, let's create the domain. We can go to the physics simulation, and now we don't have anything called Mantaflow. And if you look closely, we don't have any kind of liquid, right? Or smoke. No, we just have fluid. Why? Because Mantaflow, I said it many times, but I will repeat it as many times as needed. Mantaflow is able to simulate both liquids and smokes. Both are fluids. There are liquid fluids and there are gaseous or gaseous fluids. So Mantaflow is able to simulate both of them. So we press fluid and we define what are we defining here, what are we creating here. This is the domain. So now instead of we have domain, flow, effector, we are going to use domain. And we can see the settings. Easy, right? Now we can change from gas to liquid, or we can change different settings. We will see some of those settings. Okay, now, first thing you have to look, and you have to be sure it's correct, is the cache folder. Okay, be sure that you have the cache folder correctly configured. You can use this like a relative folder, but I'm going to create cache English, and you can use relative path or you can use absolute path. Why would you like to use absolute path? Because you may end up in a situation where you need a ton of hard drive for a big simulation. And if you need a lot of hard drive for a big simulation, you may want to work in your main drive and to have a separated drive for the cache, okay, for the simulation. So you may want to use an absolute folder because of that, or you can leave it as relative. So for me, it's cache English, accept, and it's cache English. Now I can save. Okay, next, if I press that, if I press bake data, I'm not going to get anything. Why? Because I don't have any kind of inflow, any kind of emitter. So now I'm going to get the monkey, and I'm going to define fluid and flow. Okay, flow means that it's going to be my emitter. But what kind of emitter is going to be? I can define smoke, liquid, fire, etc. So in my case, I'm going to use fire smoke. But from where do I want the fire and the smoke to be emitted? Geometry, inflow, outflow. If we use geometry, it's going to do a puff, just a puff. It's not an explosion, it's a puff. Because it's going to get the volume of the geometry, it's going to create in one frame all the volume, is going to fill all the volume with the temperature, with the smoke, etc. And the next frame is going to stop emitting and it's going to do, okay, and it's going to disappear in the end. So we don't want the geometry, we want inflow because we want a constant input of flow. What we may want to is to use the use inflow to animate the on-off status. Okay, there are two ways to animate the on-off status. One is with the use inflow, and the other one is with the scale of the object. And yes, I said scale but this is under animation, and we start with the scale applied. So keep that in mind. The scale was applied. After the scale was at 111, I could be able to work with the scale. But another solution, instead of working with the scale, is to work with shape keys. We can work with shape keys to reduce all the volume to 0, so we don't get any kind of emission. This is very good for liquids, and also could be good for smoke. But right now, I'm going to leave this like for smoke, inflow, use inflow normal, and for the time being, we are not going to configure any kind of sub-steps. Okay. Next, initial temperature, we want it to be very heat. I don't remember if this has a limit. Yes, it has a limit of 10. Let's press 2. Let's use 2. And by the way, when I use values, I don't know what those values are going to do. I mean, I know what they affect to, but I don't know what the result is going to be. Basic simulation is everything about trial and error. With time, you will get experience, and you will be able to define or to configure the best settings from the beginning or near the beginning. But you are going to iterate. You are going to need to iterate over different settings, over different simulations, once and again. So this is important to know. Don't be discouraged if your first simulation is kind of crappy. You are going to need to simulate it like 20 times, 50 times. It all depends on the shot. Okay, so let's leave this here as it is right now. Flow source, my mesh, but I could pick a particle system, and this is interesting because we are going to need that, but later. Now we can go to the domain settings. We are going to leave, for the time being, we are going to leave this in 64, and we are not going to touch anything. We are going to leave everything as it is, and we are going to simulate. So now this comes one, you are plugging part of the UI. Okay, thanks, Pablo. All right, that's it. And now it comes one important thing, and yes, one important thing in comparison with the old smoke simulator. What is it? It is that with the old smoke simulator, and many people that are used to the old smoke simulator will press play and will expect that the smoke simulation starts, and they will be like confused and saying, where is my smoke? Where? Okay, enough serious. My smoke simulator, Mantaflow, does not work by default as the old smoke simulator. By default, you have to press bake data. Why? Because in Mantaflow, you have a modular workflow, a modular pipeline. So it's more visible in liquids, but you have the same modular pipeline in smoke. You can bake data. It's going to bake the basis of the simulation, the basic data. And over this basic data, you are going to be able to enable noise, and then you are going to be able to bake the noise. If you don't want the noise settings, which is what is the same as the high resolution smoke, if you don't want the noise settings, you can scrap the noise settings, reconfigure and rebake the noise, but not the base simulation. But we can enable the replay mode. And the replay mode, as you can see, we have smoke here. The replay mode is exactly that. It's like the old smoke simulator. It's going to give us the simulation when we press play. So we can press play and we can see the result. Okay, let me do one thing. I want this to 50 frames, which is the default for the simulation. But of course, it's simulating a, not big, but it's simulating a sized domain, and then it's kind of slow. We can make it faster, of course. We can use the adaptive domain. So let's leave the monkey barn. But before we use the adaptive domain, we may want to check how this looks in render time, right? Okay, let's check. What? Where is my smoke? Hey! No, it's not inside. It's not outside. Why? Because the shader, of course. So we can go here. Let's go to the shader editor. And let's apply to the domain object. Let's apply a new material. And let's configure, by the way, a bit of intensity here. And you can see that we have a new material, but we can't see anything, right? There's nothing here. There's nothing here. Now we can create a volume, principal volume. And we connect the volume to the volume. And here it is. Here we have our smoke. By the way, as you can see, for some reason it's not it's baking, but if we go to the beginning again, I think it resets. Yes, it resets. And now it does weird things. If you want the simulation to restart, to reset, what you have to do is to go here and press anything. Okay? Any value will reset the simulation. But as you can see, what we get, what we get is just dark black smoke. Where is our fire? Because in the viewport, in the workbench, we've been able to see fire. So where is our fire? Let's stop the simulation for a moment. Our fire is there, okay, but we have to work with the black body intensity and with the temperature. So if we increase the black body intensity to 10, for example, there is our fire. 5 or to 2, okay, there we have our fire. So you are going to be able to work also with a color ramp to map this, or with any other nodes. Just play with the nodes. I'm rendering with the CPU. I'm using the CPU. It's 2990WX. 32 cores, 64 threads. So it's kind of great for render. So now we have our fire, okay? And we can increase or decrease the temperature, and this will give us different looks, different aspects. We can go to 500 and increase to 10, and we get a more reddish fire. Or we can go to this and we can go 0, 1.1, and we get like a more whitish fire. Okay, it all depends on the temperature you want to use. Just add yellowy fire, it's okay. Okay, so now we have our simulation in place, we have our shader in place, and we can start working in detailing and controlling our simulation. Because what we want to do in the end, it's an explosion, right? Okay, how many time we are? Okay, 40 minutes. 20 minutes to go. This is the reason why this is going to be a 2 parts, at least 2 parts live stream. So we want an explosion. And what is the most characteristic things in the explosion? Well, that we have debris and we have a big force that is going from the inside out, okay, from inside to the outside. It's a big explosion. Have that. So how can we simulate this with our tools? The simplest way is to use a particle system. Okay, do you remember that I told you that here we could define flow source particle system? So let's disable the simulation for a moment. Let's go here and let's configure this to modular. Okay, and let's hide the domain and let's create a particle system. If I press play, I get this. Okay, now let's do a different thing. Instead of emitting the particles from the frame 1 to the frame 200, I'm going to emit in one frame all at once, And I won't even remove the gravity. I'm just going to give the velocity like quite a big velocity, 10 meters per second. Okay, right? And now I'm going to hide this, and I'm going to pick the geometry I want to emit the explosion. I want the explosion to be emitted just from the upper part. I'm going to create a vertex group, sign. Now in the simulation, I can go to vertex groups, and in density, I define my group. And now I will get the particles just from the upper part. Okay, or at least, yeah, just from the upper part. Okay. Next, I want the floor to collide. This is important because I don't want the particles to go beneath the floor. So I go to simulation to physics, and I press collision, and I will define like a lot of damping, 0.8, a bit of randomization, 0.2, a lot of friction tool to stop the particles, 0.8, and a bit less of randomization, 0.1. Now if I press play, okay, I have my explosion. I could get a more violent explosion if I wanted by using more velocity, like double velocity. Okay, even more. This will change the aspect of the simulation in many ways, so keep that in mind. Now, how much lifetime do we want to give to the particles? We want to give the particles like a short period of time, because we want to be a burst. It's an explosion, so it's a burst. So instead of 50 frames, we are going to give this like 10 frames. Okay, or even 10 frames, or even 6 frames. No, 10 frames, yeah, 10 frames it's okay, or 8 frames, and I'm going to give in lifetime randomness 4 frames, for example, so it doesn't disappear all at once. Okay, enough for the test. The source, you can play with the particles, you can do whatever you want, and right now we have 1000 particles. We are going to do the test with far less particles, like for example 20 particles. And you may say, hey Juan, but 20 particles is not going to be anything. Yeah, it could be useful, and we will see why. So for the time being, 20 particles, plus 1. So now we save again, we go to cache, and we say, okay, bake this in, so we don't have to deal with bake all the dynamics. Okay. And of course, I just get 11 frames because there are no more particles. Okay, now I have my particles, and we can go to configure our emitter. We have our emitter here, and we can try to see what's the result. Fire smoke, inflow. Instead of flow source mesh, we are going to use particle system. What particle system? My particle system, of course. And now check this. We have set size, and we have size 1. We're going to see the result, the effects of this. Let's put this again in replay. And as you can see, now we are emitting from the particles. Okay? From the particles directly. They are like tiny balls of volumes. So let me disable the visibility of the particles in viewport. And you can see like the spots of volume, right? Now if we press play, we get this. This is ridiculous, right? Why? Because we have to give the emitter more sub-steps. So we can try to do 4, but I think we will need more. And by the way, remember to change something in the domain. to get these to effect and to reset the cache. Okay, 4 is not enough. Let's try with 8. That I think 8 is going to be okay. So let's change this. And yeah, now we have lines. We can render this and we have lines. Ooh. Okay, this is kind of debris, right? But as you can see, when the particles disappear, the lines start to fade, right? And there's smoke here. We can try now to play with our density. So let's do the same thing as before, volume info, and in this case, okay, let's use the map range. Density value from 0 to 1 to 0 to 2000. I think it was this direction. Yes, 500 for them. But these are still like balloons, like little spheres. So we can do another thing, that is increase the size. We go here and press 4, for example. We reset our simulation. Check this. Now we have a much bigger spheres. And this is the reason why I don't like the... No, I think I prefer my ramp. I'm sorry, run. And now math value and 200 to density, and the color is color. Now I can go here and I can play with this. Or I should be able, but this is the first frame. So let's increase the contrast a bit, and now we can press play and check what's happening. Okay, it's not a good result yet, but it's much better than before. So we can repeat the operation. We can try to use an 8 size. We reset, and now we get this. Okay, we can increase the black body intensity to something like 50, and this to 100, 1500, and now we get this. So it's not good yet, but we are getting something. Now we can try to increase the amount of particles. We can go here and we can delete all bakes, and we can go use like 200 particles, and let's decrease a bit the size in the emitter. Dustin, I've been stuck at this issue before. How would you vary the size of the particles so the streams of smoke are various sizes? I have not tested it, but I think that we may be able to do this by using what I'm going to do now. Let's try. Okay, let's try first this. Let's use 10 particles, and let's go to the emitter and let's use 1, and we reset the simulation, and we get what we got before. Okay, now instead of using the set size, we should be able to set the random size with the size of the particles, or I think so. So let me try scale 1 and scale randomness 0.5, sorry, it's a percentage, and let's reset the simulation. Yes, I think it kind of works. I'm not sure, but this may work. I will need to do some more testing. Let's do the particles visible in viewport. Viewport display, points. Let's try again. I'm not sure. I think this should be the workflow, but maybe not working. Set particles in simulation cells or using the nearest cell. Yes, I think it should be working. So I'm not sure why it's not working right now. I will ask Sebas. Let's try 10. We have a super big particle now. 10 is too much. 3. Okay, let's define known, and let's define halo and scale 5 and randomness 1. I think this should work, but I may be wrong. It seems it's not working. Okay, I'll ask Sebas about this, because this is an important question, I think. Of course, I think we could go to textures. Diameter were the texture? Yeah, texture. And we could use a texture to control the size, probably. But I'm not sure with the particles. It's something I have not tried. So now I will continue with the idea I had, and I will ask Sebas about this. So let me configure the size, set size, 1 is okay. Particles, 200 particles. We reset the simulation. And we have this. Okay, so let's increase the size to 3, sorry. Right, that's what I tried as well, but in my case I couldn't get any variation. You have the mass node in add. Oh, sorry, yes, I wanted it in multiply. I forgot to change it to multiply. So let's reset the simulation again. And for example, if we don't want this kind of lines, what we can do with the particles is to reset the life and set, instead of lifetime 8, we can do 3, for example, and we will get a much faster simulation, a much faster explosion. Okay, but this is just one technique for the explosion, so it's not my preferred technique. In the second part of the live streaming, I will show you the second technique, that is using geometry, not particles. I think it works best. It was the better. So now we have this, and we need like more fuel, because we want a lot more of fire going out. Okay, so we need more fuel. Let's increase. I don't know if we have like a limit of 10. I don't know why the limit is 10, but let's try with 3 as fuel. Initial temperature 3. I want it to rise faster, and heat. Yes, it's going to rise faster if I increase this. And we can, I can use dissolve, but I won't use dissolve. And vorticity, is there a limit in vorticity? Yes. So 1 of vorticity. Buoyancy density is okay, and we can enable adaptive domain. So now we can try. It's much faster, or it should be much faster, but it's still ugly. Why is it ugly? Because we have a very low resolution. So now what we should do, it could be cool, but what we should do is, first we are going to enable the cubic interpolation. Settings, cubic, and it improves the overall aspect. Second, I should increase the subdivisions, but not to 600, I could increase this to just 100. But another thing, I won't do it because I don't want, well, let's try, but if it's too slow, I will remove it. They are very ugly. Let me increase the size of the particles to 6. I prefer like big balls of fire. And I have not resetted the domain. And it's slow. 3 frames, the particles are dead. It's kind of slow, right? So let me go back to the 64 subdivisions. 64 subdivision for time being. And now we can press this. Okay, before I go with the noise, which is what I'm going to do now, just before the end, let me configure this as modular and let me bake. I prefer to bake the simulation. I think it's a bit faster and I think it's more comfortable. Now, while it's baking, let me stop for one moment and let me go down here. We can use different formats for the simulation. One of them is OpenVDB, and we could use this OpenVDB to be read in other softwares, and we can use this OpenVDB to use our smoke simulation as an asset with the new OpenVDB or volume object. The new volume object that is right now, it's under development by Brecht van Lommel. It's going to allow us to load OpenVDB cache from Houdini or from other softwares or from Mantaflow. So this is important to know because you are going to be able to manage the simulations as simple objects that you could repeat, duplicate, or whatever you want. So let's resume the simulation. Now it's faster because smoke is dying. And that's it. We can go back and we can play. Why is it disappearing? Let's free the data because we don't have any. We have the adaptive domain, but okay, let's remove the adaptive domain in case this is doing something weird. And we have, you can see OpenVDB, raw cache, or unicache. OpenVDB is the default now, I think. And let's bake the data again. I think since it has some old data from the playback mode, it should give some problem. Yeah, it's slow. You gotta check out Embergen. I know Embergen, and I will get a license of Embergen as soon as I can because it's very interesting. Sebas know Embergen too, and he really liked it. So I think it could be interesting to understand what they are doing under the hood. Because at first it was unable to explore OpenVDBs, and later it was unable to have collisions. Right now I don't know if it's able to collide with deforming objects or not. It's one of the most difficult things, because colliding with a static geometry that is just transformed, it's kind of cheap or easy, but colliding with a deforming mesh like a character is way more expensive. But it's pretty cool. Embergen is super cool. Okay, now we have our simulation. Right, we have our box of fire, and now we are going to enable noise. And what's the first thing that will happen when you press noise? The simulation will disappear. Okay, we have the simulation, we don't have the simulation. Don't panic, the bake is there. You can see here that you have free data. Why? Because the bake is there. It's just that when you enable the noise, it's going to show you the result of the noise bake. Since you don't have the noise baked yet, you won't see anything. So the first thing I do is I go here, and we can try with a high resolution address, like 4 for example. And later we could, it will have to be in the next streaming because we are already in 1 hour. But we could play with these values to get different effects. For the time being, I'm going to test this, and that's it. And it's kind of slow because I gave it 4 as a press value. In fact, it's not slow, to be honest. And by the way, I want to show you how is it leveraging all the 64 threads. So the hyper-threading, the multi-threading of Mantaflow has been improved a lot in the latest times. So it's slow, but at the same time, it's not so slow. For simulation, this is not so slow. And yes, I know MPG. And yes, I know that now they can export OpenVDB, and that's the reason why I'm interested in acquiring a license. And if I'm right, I think they sell perpetual licenses, right? Because without a perpetual license, I won't get it. But with a perpetual license, I will get it. And I will probably pay for the upgrades, but it has to be perpetual. I'm sorry. I don't like rental licenses. Okay, we can stop now. Oh well, the smoke is going to disappear soon. So it should be faster now. Come on. Okay, I will stop now. So now we have the result from the frame 0 to the frame 23. And we have a crash. Woo. Oh, it was an OpenVDB crash. Let's get the latest autosave. Recover autosave. So we had the noise enabled? No. We were here and we were in modular. Yes, so probably we have this. Right. Okay, let's try like a lower value for the noise. And we have the noise compute, but it has to be 4. And now it's in place. So we can press play. And you can see that we get much more detail. We can go to render. And we get much more detail. Still soft, I would go to 6 as average factor. So I will go to 100 or 150 as subdivisions. And then I would go to an average factor between 4 and 8. If my machine can support it, I will do like between 4 and 8. Hello, hey! I was here. Blender also crashed. Yes, of course. Blender can crash. Especially if you are using 2.83 alpha. Okay? In older streaming, 1 crash. Yes, I can make Blender crash in many ways. It's not so hard. It's just that it doesn't use to crash. Okay, so you can see that we get a much more detailed simulation, and now we can start playing with the detail. Let's advance in the timeline. Hello? Come on, load. Load. So you can see that we get, especially in animation, when this is rendered, we took a very low resolution simulation and we use the noise with an average factor of 4, and now we get a much more detailed simulation. So this is the real power of the noise. By the way, apart from this, right now I think it's underworks an up-res feature. not just to do the noise addressing, but the actual domain addressing. So this is going to be very cool. So now we can decrease this a bit, like 30 or 25 on 1000, no, 1000. This one to 30. Okay, and we get like more fairy, more fire explosion. Fiery or fairy, you know, fairy is like the fairy tales. I don't know how to call it. You don't think Embergem sells perpetual licenses? I think they do. I don't know why, but I think they do. I will check it. I will check it. Okay, we got this, but now if we go near the smoke, we have the cubic interpolation, so we don't get weird things. We can increase the contrast. Okay, so we get more contrast, but for the fire, I don't kind of like that's a big contrast. And I lost the beginning. Can you emit from surface or only from points? Both. You can emit from surface. You can enable also the volume of the object to emit, and you can use the particles. In this case, I'm using the particles, but you know better than me, Eloy, the best techniques for this kind of things. But I don't quite like the particles technique. I prefer to use a geometry and a texture to control the emission and drastically, heavily deform the geometry and such things. But I will do that in the next streaming because I'm over an hour now. But now, if I want, I want to tell one thing, one quick thing, that if we want more detail in the smoke, what we could do is to work with 3D noises. So if we go here and we create, we look for noise texture, we can check how can this affect our density. If we go here, I think it was, yes, I think it was here. Now we are multiplying this by 200 and this by 200, but now we are going to use the factor. Yeah, Embergen is perpetual or monthly, which will add up to perpetual. That's the good thing. It's great. I'm all for the rent, the monthly rental that gets you to own the software. I'm all for that. It's okay. Okay, you can see the effect that we get with the noise. Okay, if we connect this here, and let's run this. Okay, and now we connect this here. Still, we don't have too much effect. So let's add a mapping vector, and now we can increase the scale or decrease the scale, like 5. I don't remember the values right now. Let's try 0.1. No, why I'm not seeing any effect? Because probably I have to multiply this after. After the multiplication in the density. So I'm going to get this. I'm not sure, to be honest. Okay, it's not affecting a single thing here. Why is it not affecting? Let's try Musgrave. And now we can see some effect. Okay, we can increase this a lot. 300, 500. It all depends on the aspect and the kind of detail we may want. And 800, and we get like tiny noise in the fire. And now we can try to do the things the other way around. That is, I'm going to do this and this here and this here. $1,000, and let's reduce this to 20, for example. So as you can see, we can get thin detail, and this needs more work. Okay, this needs quite a bit more work for the spec, but you can get more thin detail if you work with 3D textures to deform the smoke. And you can use not just one, but 2, 3, 4 textures to get different effects. Right? It all depends. Also, you can use a map range or a color ramp to control this effect. Okay, so you can get this kind of fireball or sun effect. Shiny sun. We can lower this to 5. And still the density is pretty low. I don't know why. I don't know why it's affecting so weirdly, but yes, you can get this kind of effect. So playing with different noises with different 3D noises, you can get different effects and get more detail for the simulation. Dusty, maybe it's because you are on Linux. I have a Threadripper too, and your interactivity with these volumes is way better than mine. The first thing I did when I purchased this CPU was to get rid of Windows. Windows was getting me way lower performance. It was not leveraging properly all the threads, and I shifted to Linux directly. I didn't think about it. It's just I need Linux. That's it. And since then, yes, the interactivity is very good. It's very, very good. So, okay, I should see what's happening here. Why I'm not making it to get more density. But this is basically the overview of the technique. We could use the mapping and such and those things, but okay, come on, load. Hey, Oliver. Can't stay to watch live, but keep it up. I will finish now, so you will be able to see it recorded later, tomorrow probably, or I don't know. Yeah, tomorrow. Okay, so that's it for the. Hey, thank you, Oliver. That's it, more or less, for today. I will do another live stream. It's a pity you do the donation now. It's a pity. I'm going to finish. Okay, so let's connect this here and see the final volume. It's much prettier now with this. As you can see, something weird was going on with the multiplication. I'm not sure what was the problem. Thank you, man. Let's check what happens here. Did you pick the noise? Yes, I picked the noise up to the frame 23, I think. Okay, this is killing it. I don't know why. Let's try add. As well, we get something with that, but I can't see any detail. Something is weird with the noise, to be honest. Right now, something is weird with the noise. Multiply add. No, something is weird with the noise. We can try what happens if we lower this. No. This is too white. And yes, it changes, but okay. Yeah, we can recover some of our detail this way. Oh, much better. and we can try the scale and see the effect 20 for example, and there is no effect. There is barely no effect. Yes, we can see something around here, but I don't know, something is weird right now with that. So let me put this to black again, and you can see the weird effect we can get here. But in the end, the important thing is that you are able to play with these values, with these noises, to get more variation, more detail in the simulation. So I think that's it for today. What version of Linux you are running? I'm on Linux Mint. Linux Mint, I don't remember the exact version. The latest Linux Mint. I may try in the near future Pop OS or pure Ubuntu. This is Ubuntu based, but I may change it. So this is it for today. 1 hour 16 minutes is more than enough of rambling myself. I hope you learn how to set up a quick explosion with particles. Many things can be improved, many things can be refined, but well, you can make things go boom now, kind of. It's just an introduction, come on guys. Okay. That's it. Thank you for watching the live streaming. I hope you liked it. I hope you learned something about the live streaming, about the Mantaflow, the smoke simulation, the new smoke simulation system in Blender. And I hope you enjoyed it. You had a great time. And if you liked it and you want to see more videos and you want to be warned about other live streaming and other uploads, just subscribe to the channel, because the 50% of you are not subscribed. I know that. I have the data. Subscribe to the channel and press the little bell. I promise I won't be publishing things all the days. No, I don't have time to do that. So subscribe to the channel and press the little bell, and I'll see you in the next live streaming. Thanks everyone. You can follow us in @BoneStudioAnim. I will put that in the where's my mouse? Here. I will put that here. You can follow us in Twitter and Instagram in @BoneStudioAnim. So see you in the live streaming. Thanks everyone, and we will see the more of this in the second part. Bye.